In this example, we're going to simplify radical expressions that involve both multiplication and addition or subtraction. Similar to simplifying expressions that have variables in them, we can only add or subtract expressions that have the same variable. 4x plus 3x is 7x, but 4x plus 3y can't be simplified. Similarly with radicals, the only way to simplify a radical expression with addition or subtraction is if the radical factors are identical. So in part A, we have 4 root 7 plus 9 root 7, because both of these have root 7s. This is very similar to being given 4x plus 9x. We know from our past experience, 4x plus 9x, we add the 4 and the 9 and we get 13x. Because 4x plus 9x is saying we have 4 x's, we're going to add 9 more x's, so in total we'll have 13 x's. The same is true about the radicals. 4 root 7s plus another 9 root 7s will give us 13 root 7s. So you can add radical terms if the radicals on those terms are identical. Now when we look at part B, we have 5 root 27 minus 11 root 12. In some ways this seems like it might be the same thing as 5x minus 11y. Because those radicals are not the same, it would appear that they are not like terms. But one difference between the variables and the radicals can often be simplified. The square root of 27 can be reduced down to something simpler. Same thing with the square root of 12. So before we stop and say there's no way to simplify this, we need to always reduce our radical factors. So looking just at 5 root 27, we'll take that 5 root 27, specifically the root 27, and we'll recognize that 27 is the same thing as 9 times 3, 9 being a perfect square. And so we can rewrite 5 root 27 as 5 times the square root of 9 times 3. And using our multiplication property, we can separate out the square root of 9 from the square root of 3. And this would give us 5 times the square root of 9 times the square root of 3. Again, the reason for doing this, that square root of 9 will simplify to 3. So this becomes 5 times 3 times the square root of 3. And 5 times 3 times the square root of 3 becomes 15 root 3. Now we're going to do a similar thing to the other radical that we had been subtracting, 11 root 12. So if I'm subtracting 11 root 12, I need to recognize that 12 is the same thing as 4 times 3. Again, 4 being the perfect square, which makes that important. So I will rewrite that minus 11 root 12 as minus 11 times the square root of 4 times 3. Which I will simplify down to become minus 11 times the square root of 4 times the square root of 3. Again, the reason for having done this is that square root of 4 will become a 2. It simplifies. So we end up with minus 11 times 2 times root 3. And simplifying that one step further, 11 times 2 is 22, so this becomes minus 22 root 3. Now going back to the original expression, 5 root 27 minus 11 root 12 did not appear to be like radicals. They were not like terms, so we couldn't do anything. But having simplified each radical on its own, we have now transformed this into 15 root 3 minus 22 root 3. And now, because these are both root 3 terms, we can subtract the coefficients. 15 minus 22 is negative 7. So 15 root 3 minus 22 root 3 becomes negative 7 root 3. So the trick when adding and subtracting radicals is don't take the radicals at face value. Always try to reduce a radical, because maybe you will be able to combine like terms.